Hello everyone. Today we are going to learn about a new chapter, that is confidence interval for one population mean. In that, the first section is estimating a population mean. A common problem in statistics is to obtain information about the mean mu of a population. For example, we might want to know the mean gas mileage of a new model car. If the population is large, the computing its mean is extremely expensive or even impossible. In this lesson, I'm going to introduce and we are going to look at some methods to obtain information about mean mu. Okay. So the first definition is you need to know in this chapter is point estimate. A point estimate of a parameter is the value of a statistic used to estimate the parameter. Okay. A point estimator of a parameter is the value of a statistic used to estimate the parameter. According to the definition, if we check the parameter as mu, which is the population mean, we can use a point estimate to obtain information on mu. So the point estimate which tells us about the mu is the sample mean. That we denote it as x bar. Okay, the point estimate for mean mu is the sample mean, that is x bar. This can be calculated by dividing the sum of sample data by the sample size n. As you can see in this formula, the x bar can be calculated by dividing the sum of sample data by the sample size. Okay, now let's move on to an example of estimating mu by x bar. Here in this table we have annual price figures for 36 new mobile homes, and they are in thousands of dollars. Okay, the data are in thousands of dollars. So the only thing that we need to do is to estimate the population mean price is find the sum of the prices and divide it by 36. That is the number of new mobile homes that we have in our dataset. Now we have this summation of prices as 2278 and the number of observations as 36, and if we divide 2278 by 36, we will get 63.28 as x bar. So we can say that mu is approximately 63.28 thousand dollars. That is 63,280. Okay, 63,280. Yeah, that is the approximation that we obtain using the sample data, that is x bar. Right, let's move to the next slide. The next method that we can get information about population mean is by confidence interval estimate. So let's see its definition now. There are two important words which describes a confidence interval estimate. They are confidence interval and confidence level. There are two important words. Those are confidence interval and the confidence level. The confidence interval is an interval of numbers obtained from a point estimate of a parameter. Okay, and the confidence level is the confidence we have that the parameter lie in the confidence interval. First one, the confidence interval is an interval of numbers obtained from point estimate of a parameter, and the second one, the confidence level, is the confidence we have that the parameter lie in the confidence interval. And usually the confidence interval estimate gives more accurate information about any parameter than that of a point estimate. It's because we can never say that the parameter is always equals to the estimate, the point estimate, which is heavily dependent on the sample. There is always sampling error in the case of a point estimate. So the calculation of a confidence interval estimate is more accurate than rely on point estimate. Now let's move on to an example again. This is the example data that we obtained for the first example. Now we are going to calculate the 95.44% confidence interval for mu when sigma equals to 7.2. That is the standard deviation of the dataset. And we are going to assume that this dataset follows a normal distribution. Okay. All right. From the previous example, we already have that x bar is 63.28. That's what we calculated from the previous example. That is our point estimate, and we know that the population standard deviation is 7.2, and using this formula we can calculate the sample standard deviation. That is standard deviation of sample, that is the population standard deviation divided by the square root of n. Okay, that is n actually equals to 36. So that basically means 7.2 divided by 6. That will give you 1.2. We know that 95.44% of all possible observations lies within these two standard deviation to either side of the mean. Okay, we already know that the 95.44% of all possible observations lie within two standard deviation to either side of this mean. Some mean prices are within 2.4 of mu. Yeah, that's it. The mean prices are within 2.4 of mu for any side, for the left side or for the right side. Okay, so the lower bound is found by subtracting 2.4 by x bar. That is subtracting 2.4 by x bar, that is 65.83 minus 2.4, that is 63.43. Okay, and the upper bound, we can obtain the upper bound by adding 2.4 to the x bar. That is 65.83 plus 2.4, that is 68.23. The 95.44% confidence interval for mu would be from 63,430 to 68,230. That is our lower bound and the upper bound, the lower confidence level and the upper confidence level. Those two we call as the confidence interval. Now we are at the last section of this last slide of this lesson, that is interpreting the confidence interval. This table shows the sample means and 95.44% confidence interval for 20 sample data sets, which has the population mean as 65. Okay, the last column indicates yes if the population mean is within the confidence interval of respective sample, and indicates no if it is not. Okay, as you can see, there is only one no here. It's because this interval doesn't include 65 in here, because it's from 65.33 to 70.13, right? So we can say that mu lies in the 95.44% confidence interval in 19 out of 20 samples. that is in 95% of the samples. I will repeat again. As you can see, there are 20 samples and only one of them doesn't have the 65 within its interval, so 19 out of 20 have 65 included in the confidence interval. So altogether 19 divided by 20 and get the percentage, we will have 95% confidence interval. Alright, that will be the end of this section and I will see you in the next section. Thank you.